Okay.
Can you able to hear me now? Hello? Can you able to hear me now? Hello? Hello? So
So
hello
hello
everyone,
everyone,
I am
I am
Himanshu,
Himanshu,
and
and
we will
we will
start with
start with
what we
what we
left
left
in the
in the
previous week.
previous week.
So there
So
was
there
one
was one
question
question
that
that
I
I
asked you
asked
to
you to
solve.
solve.
So
So
let's
let's
solve
solve
that
that
question.
question.
So the
So the
question is
question is
based on
based
the
on the
same
same
concept
concept
that we
that
have
we have
discussed
discussed
previous
previous
week.
week.
That is to
That is to
calculate
calculate
the
the
resultant
resultant
force and the
force and the
resultant
resultant
movement
movement
of a
of
given
a given
system.
system.
So in this
So in this
question, we have
question, we have
given
given
that the
that the
vector sum
vector
of the
sum of the
forces
forces
acting on the
acting on the
beam
beam
is
is
0,
0,
and the
and the
sum of
sum of
movement
movement
about
about
A,
A,
this
this
point
point
is
is
0.
0.
What are the
What are the
forces
forces
Ax,
Ax,
Ay,
Ay,
and
and
B?
B?
And
And
also we
also
need
we
to
need to
calculate the
calculate the
sum of
sum of
movements
movements
about
about
B.
B.
So
So
earlier
earlier
we
we
solved
solved
many
many
problems
problems
where
where
we
we
calculate the
calculate the
overall
overall
resultant
resultant
force,
force
a
or
total
total
force,
force
or the
or the
total
total
movement.
movement.
But in
But
this
in this
question we
question,
have
we have
given
given
that
that
the
the
sum of
sum of
all the
all the
forces
forces
is
is
0,
0,
which
which
means
means
that
that
forces,
forces,
sum of
sum
all
of all
forces in
forces
the
in
x
the x
direction is
direction is
0,
0,
as well
as
as
well as
sum of
sum of
all
all
forces
forces
in the
in
y
the y
direction is
direction is
0.
0.
And the
And the
movement
movement
about
about
A,
A,
overall
overall
movement about
movement
A is
about A
also
is
0.
also 0.
And we need
And
to
we need to
calculate
calculate
Ax,
Ax,
Ay,
Ay,
and B.
and B.
Okay,
Okay,
so
so
we can
we can
use these
use
three
these three
conditions
conditions
to
to
calculate these
calculate
three
these three
unknown
unknown
quantities.
quantities.
So we
So
will
we will
be
be
writing three
writing three
equations
equations
because there
because
are
there are
three
three
unknowns. So
unknowns. So
we will
we
be
will be
writing three
writing three
equations
equations
from these
from these
conditions we
conditions
have
we have
given.
given,
And then
and
we
then
will
we
be
will be
solving
solving
three
three
unknown
unknown
quantities. And
quantities.
in the
And in the
second part,
second
we
part,
will
we
be
will be
calculating
calculating
overall
overall
movement
movement
about
about
B.
B.
So
So
let's
let's
start with the
start with the
first
first
question.
question.
So
So
for this
for this
force,
force,
we can
we can
actually
actually
take
take
the
the
component.
component.
So this
So
is
this
our
is our
horizontal
horizontal
component,
component,
which
which
is
is
400
400
cos
cos
30,
30,
and this
and this
can be
can
our
be our
vertical
vertical
component,
component,
which will
which
be
will be
400
400
sine
sine
30.
30.
So if
So
I
if I
take the
take the
summation of
summation of
force
force
along
along
x
x
direction,
direction,
which is
which is
0
0
as
as
given in the
given in the
question,
question,
then
then
we
we
have
have
400
400
cos
cos
30
30
plus
plus
ax
ax
equals to
equals to
0.
0.
So
So
these two
these
are
two
the
are the
only
only
horizontal
horizontal
force we
force
have,
we have,
ax
ax
and
and
400
400
cos
cos
30.
30.
So this
So
is
this is
equation 1.
equation
So
1.
we
So
can
we can
also
also
write
write
ax
ax
equals to
equals to
minus
minus
400
400
cos
cos
30.
30.
So
So
ax
ax
will
will
be
be
minus
minus
400
400
to
to
3 by
3 by
2,
2,
which
which
will be
will be
minus
minus
346.1
346.1
kilonewton.
kilonewton.
So this
So
is
this
our
is our
ax.
Ax.
Similarly, we
Similarly,
can
we can
use
use
resultant
resultant
force in the
force in
y
the y
direction to
direction
be
to be
0,
0,
and
and
the
the
y
y
force
forces
forces along in the y direction, we have B, we have AY, and we have this 400 sine 30. So we have overall three forces. So AY and B are in the same direction, and 400 sine 30 is in the opposite direction. So this is the sum of all the forces in the y direction, which is equal to 0 as given in the question. So I can write this as AY plus B minus 200, because this quantity is 1 by 2, which is multiplied by 400, so it will become 200. So this is, let's say, our second equation. This was our first equation. So here we have two unknown, so we cannot directly solve this equation. So let's make another equation which is in movements. So in the question we have given that movement about A is 0. So movement about this point is 0. So we will take the movement about this point and equate it to 0. So the sum of movements will be due to this force, which is rotating about counterclockwise direction, B, and it has a perpendicular distance of 500 millimeter from force B to point A. So this is our point A. So let me use counterclockwise as positive and clockwise movement as negative. So it will be B 0.5 meter. Then there will be a movement due to this force as well, which will be rotating in a clockwise direction around point A. And the perpendicular distance is this, which is 200 millimeter or 0.2 meter. So since it's a clockwise, it will be minus 400 cos 30 multiplied by 0.2. Then that's it. So there will be only two forces which creating the movement, and the other forces is actually don't have any perpendicular distance, so there will be no movement from the other forces. For example, there will be no movement from AX, AY, as well as this 400 sine 30, because there is no perpendicular distance from point A to various forces acting. So only two forces are there, and we can solve this. So we already know 400 cos 30, which is 346. So B will be 346 multiplied 0.2 divided by 0.5. So B will be around 140 kilonewton meter. So we know B now, and we already found AX as well. So now we can use equation 2 to calculate AY. So AY plus 140 minus 200 equal to 0. AY minus 60 equal to 0. So my AY will be 60 kilonewton. So we calculated AX, AY and B. So basically we have calculated all the unknown forces. So this part is done. So now the second part is what is the sum of moment about B? So now we need to calculate the overall moment about this point B. So it's a straightforward exercise. So the moment about B will be equal to, first we need to identify the forces which are creating the moments. So this is 400 cos 30. This is 400 sine 30. And we have AX, we have AY. So AX was minus 346 kilonewton, AY was 60 kilonewton, and B was around, I don't, around 40 kilonewton. So the moment, so the forces which are creating the moment is this 400 cos 30, because we have a perpendicular distance this from the application of force till point B, and this is the perpendicular distance, which is 200 plus, sorry, 220 plus 260 millimeter. And again I am considering counterclockwise as positive, and the direction of this force is around point B is clockwise. So it is minus 400 cos 30 multiplied by 0.22 plus 0.26. These are in meters. Then there is this force. So earlier it was not causing any movement to point A, but now it is, there will be a movement because there is a force has this direction, and it will create a movement along this direction. It is rotating in a counterclockwise direction, and there is a perpendicular distance, which is this zero 0.5 meter. So 400 30, this is the force, and the perpendicular distance is 0.5 meter. Then there are AX and AY, both will create the moment around point B. So this AX will rotate it in a clockwise direction around point B, and this is the perpendicular distance, which is 0.26 meter. Minus AX was minus 346 multiplied by 0.26. And then there is force AY, which is again rotating in clockwise direction, and it has a perpendicular distance of 0.5 meter. So minus AY, which is AY is 60 multiply 0.5. So this is the overall movement about point B. So we will calculate. So the first term is 166.276 plus 100 plus 90 minus 30. So I'm getting a moment about minus 6 kilonewton meter. So this is the moment, overall moment along point B. So just to recap here, so we have given a figure here, and we want to first we have given three conditions that the resultant forces in the x and y direction are zero, and the moment along point A is also zero. At this point is also zero, and we need to find the force. We need to find the force ax, ay, and b. So we use these three conditions to write the three equation of motion. So the equation of motion are similar what we are doing from the previous week. Only difference is this r is zero. Sorry, this rx is zero as per given condition. And we use this three equation to find the three unknown forces. And then in the second part, we have been asked to calculate the overall moment at about point B. So in the first case, the overall moment about point A is zero. So what we did, we have the summation of movement, which is equal to zero, and we calculate the unknown moment. In the second part, we have the overall we need to calculate the overall movement, which will again given in terms of summation of movement, and we calculated this quantity. So both were straightforward calculation, and as per the condition given, we have use the equation to solve the unknown. So any doubt here in this problem? So if not, then we can move to next topic. So our next topic will be equilibrium. So until we have talked or we have solved few problems where we try to deal with the overall resultant forces. And the overall momentum about any random point. So until now we are actually calculating these total quantities like total forces or total moment about one point. But in engineering mechanics, especially in the statics, the equilibrium concept is very important. So there are three conditions. So here I'm just revising. I'm not going into very much detail like in the NPTEL lectures. But I am going to revise a few things and then we will again start solving questions. So for the equilibrium, we have a three condition. The first condition is Rx, which is equal to summation of fx should be zero. The second condition is Ry, or the resultant force in the y direction, is zero, and the summation of movement about any point should be zero. So these three condition actually is a sufficient condition to satisfy the equilibrium. So if you have an equilibrium system, which means it should satisfy these conditions, at most these conditions. So studying the equilibrium system is very important because most of the systems that we are actually studying are constant. They are not moving. And if they are constant, they are not moving, which means they are the overall resultant force or the moment are zero. For example, let's say you have a wheel. If it is rotating at any angular with any angular velocity and having some finite angular acceleration, this wheel has some movement. It has some overall movement, but if the rotation of this wheel is constant, this wheel is not rotating, then this overall movement will be zero. Similarly, let's say you have a block and you are applying some force, and this block is moving with some velocity v and may have some acceleration a. Now let's say you are again applying this force and you cannot able to move this block. It is not moving, which means this block is in an equilibrium position and the overall resulting forces are zero. Now again consider the same block and it is moving in the x direction. So you can say that the overall resultant force in the x direction is not zero, but overall force in the y direction is zero, because this block is moving in the x direction, which means there is no equilibrium in the x direction, but there is equilibrium in the y direction, because this block is not moving in the y direction. It is only moving in the x direction. So there is a equilibrium condition here, but not in the x direction. So equilibrium condition actually is satisfied when all the forces and the moment are zero. So in the previous lecture, we actually studied about this system when there is a finite resultant forces and finite movement is actually occurring. We actually ignore the internal forces because internal forces create a deformation in the body, create the shape change in the body or some kind of deformation of the body. And we assume that we don't want to study these deformation. So internal force, we are not considering the internal forces. Now in this chapter, we have assumption that all the systems that we will study are constant in some ways. So they are constant, which means the overall forces or the movement will be zero, and we need to find the movement or the forces in some part of these bodies. So this equilibrium principle will help us to find the unknown forces and unknown movement, provided that the overall or resultant forces are zero. So the assumption is our body is constant or some part of the body is constant. For example, let's consider a roller connection. So this is a fixed surface and you have some roller support here. So whenever you have a connection or you have some support, there will be a normal reaction that we have seen previously in many problems. So there will be we have to find some normal reaction. So here also we will have a normal reaction, we will have a movement or the normal movement or the overall movement which is acting at this joint. So in the roller connection, what happens that this roller can actually move in the horizontal direction. Okay, but it cannot move in the y direction. So there is a constant in the y direction, which means there will be some normal force which will acting here, ry, because it's a constant. It cannot move in the y direction, and therefore, according to the Newton's third law, there will be equal and opposite force which is acting at this joint, which is ry. There will be some forces here. There will be many forces acting on the system, and the equal and opposite forces act in the y direction, ry. There will be no force in the x direction because this roller can move in the x direction. So there will be no resultant forces. Similarly, let's consider a pin connection. So here, this is our pin connection. So now it cannot move in the x direction and also in y direction. So the motion is now constant in both x and y direction, which means there will be a normal component of force which are acting, ry and rx. So these normal force now which will be acting in this joint with the pin connection, because there is no constant motion in any of this direction. Then there is a fixed support. So this is a wall and there is a fixed support here. So in such support, we have axial force. Axial force means it's act along in the axial direction. Then there will be a shear force V here, a vertical component of forces, and then there will be a movement as well. So these three things will be acting at the end of this beam. So whenever we are working with fixed support, we need to concern about movement as well as two component of force. Whenever we have a pin connection, we need to concern about only two component of force, and whenever we have a roller connection, we need to concern about only one component of reaction forces that we will see in the question. So basically, these are important when we study about the shear force diagram or the bending moment diagram of different beams, and that we will see in the future lecture or in the subsequent classes. So they so these are the different kinds of forces, the reaction forces which are actually acting on the system. And this is the principle that in this class we will be uh, using it to solve the most of the problem. Even in the next class, when we will discuss the trusses, forces and trusses, we will be using the same principle, equilibrium principle. So this is the most powerful method to find the unknown forces or the unknown movements, given that this any part or the whole system is a constant, which means it cannot move. So let's move to the first question, or let's solve a very simple question first, just to understand how to solve the problem when we apply the equilibrium principle. So let's consider a system. So these are the different connection we have, and there will be forces acting on each connection. Let's say here we have 8 kilonewton. Here we have 16 kilonewton. Here we have 3 kilonewton force. Here we have unknown force T, and here we have unknown force C. We have angle 20 degree, and here we have angle of 40 degree. And this is my coordinate system, X and Y. Okay, and now here we need to find the unknown force C and T. And we will assume that the system is in equilibrium. Okay, which means that the overall summation of force in the x direction is 0. And using this condition, we can able to write down the force balance equation, which we have T cos 40. So basically I am writing this component of T, which is T cos 40. There is plus 8 minus 16, which is in the x-axis but in the negative direction. Then we have component of this force, C. Which is plus C sine 20 equal to 0. So from the equilibrium position, the summation of all the forces will be equal to 0. So this is our equation 1. And then we have a second equation where the summation of force in the y direction should be equal to 0, which means minus 3 minus C cos 20, and then there is a T sine 40 plus T sine 40. Just be aware about the sign. So this is minus 3 because it's acting downward, and the C component is also acting downward, so it's minus C, and the T component of force is acting upward, so it's positive. So Just be aware about signs and all. So this is equation 2. So now we have a two equation and we have two unknowns, T and C. So we can easily solve this equation. So I can simplify the equation 1 as T multiply 0.766 minus 8 plus C multiply 0.342 equal to 0. And the equation 2 will be simplified as minus 3 minus C multiply 0.93 plus T multiply 0.642 equal to 0. So I can write T as 3 plus 0.93 C divided by 0.642. So this is my T. I can substitute T in equation 1. So I will get here 3 plus 0.93 C 0.642 multiply 0.766 minus 8 plus 0.342 C equal to 0. So now this equation is given in terms of C only. So we can easily find C. So when you solve this, you will get C as 3.03 kilonewton. Then you can substitute C here in this equation. So T will be 3 plus 0.93 multiplied by 3.03, which is C, divided by 0.642. So when you solve this, you will get T as 9 kilonewton. So this is our T and this is our C. So we can easily find from the equilibrium principle. So it's similar to the previous question we have solved. So until now, any doubt? So any doubt? Hello, can you hear me? So any doubt until now? Hello, can you hear me? Okay, you can hear me, right? Because I just switched the speaker. So just want to check. Okay. So let's solve first problem. So here we have, if the 1.5 meter long cord AB can withstand a maximum force of 3500 Newton, determine the force in cord BC and distance Y so that the 200 kg crate can be supported. So you can just see the question and you can find that you need to use the equilibrium principle. For example, here it is says that we need to find the force and distance y such that this 200 kg crate can be supported. So you need to hang this crate, you need to support this crate, which means the system should be remain in equilibrium, otherwise this crate will fall down and the equilibrium of the system will lost. So to support this system, the support this crate, the system should remain in the equilibrium. So we will be using the principle of equilibrium here to calculate the unknown force and the distance y. So so in equilibrium problems, it is always advisable to make a free body diagram first. So for example, let's say this is your point B and this is A and this is C and this is the force, which is 200 multiplied by 9.81, which is basically W mg. So G is 9.81 and 200 is the mass. And we have given the distance 2 meters. So basically in the free body diagram, you need to first represent all the forces. Distance is not necessary, but since we need to find the distance here, I am drawing distance as well. Okay, so first consider the forces along the y direction, which should be 0. So why I choose the forces along the y direction? Because I can actually balance the weight with the component of this force acting in this AB chord. Okay, well, let's say this is angle theta. So then it will be, and it is also given that this AB chord can withstand maximum 3500 Newton force. So this force AB is 3500 Newton and this is 1.5 meter in length. So it's 3500 Newton. Since we are concerned with the y direction, we need this component of force, this one. It will be 3500 sine 30, sorry, sine theta, minus this weight. We are balancing with this weight. This is the only other force in the y direction. So it's 200 multiplied by 9.81 equal to 0. So only unknown quantity here is theta. So we don't know theta. So it will be 3500 sine theta equals sine theta will be 1962.3500, which is theta equals to sine inverse 1962.3500. So when you calculate this, you will get theta as 34.1 degree. So this is your theta. So you can see that you actually obtain theta. You already know this length, which is 1.5 meter. Then you can easily found this length y. Right? So y by 1.5 equals sine 34.1, which means y equals 1.5 sine 34.1. So y will be 0.84 meter. Okay, so this angle we got when we do the force balance analysis in the y direction. So now if we do the force balance in the fx, which should be equal to 0 as per equilibrium. So now we have a force which is in BC, and the force horizontal component of this force, this one, which is FAB cos theta. So these two forces are balancing each other, or these are the only two forces which are in the x direction. So force BC minus cos 34.1 equal to 0. So force BC will be 2898 kilonewton, which is roughly equal to 2.9 kilonewton. So this is my force, unknown force BC. So we have calculated whatever we have been asked in the question. So we just do the force balance under the principle of equilibrium, and we saw that when we do the force balance in the y direction, we actually can able to recover the unknown theta. So it's not just force or movement, unknown force or unknown movement that we can actually get from the force balance analysis. You can actually get any unknown quantity. So here the unknown quantity was theta, and you can able to get that when you do the summation of force equates to 0. When the summation of force in the x direction equal to 0, the only unknown quantity was force in the BC, and you can able to calculate that. Now let's say you have a two unknown quantity, you have one more unknown quantity, let's say it's x. So there were two unknown quantities now, f, b, c and x. So in that case you need to use third equilibrium condition, which is summation of movement about some any point, and this should be equal to 0. So then this, when you write this equation can be given in terms of f, b, c and x and some known quantities. So now you have two unknown quantities here, and using this two equation you can actually able to calculate f, b, c as well as x. But luckily we have only f, b, c as an unknown quantity in the equation, so we don't need to use for now. For now we don't need to use this moment equilibrium equation. So any doubt in this question? So let's move to the next one. So next one also a bit similar one, similar question. So here the towing pendant AB is subjected to the force of 50 kN exerted by a tugboat. Determine the force in each of the girders BC and BD if the ship is moving forward with a constant velocity. Okay, so now the another hint that you have to use the equilibrium condition is this: the ship is moving forward with a constant velocity. So which means the overall force should be 0, because according to the Newton's law the force is given by ma, right? So if the overall force is not 0, which means the acceleration is not 0, but in the question we have a constant velocity, we have given a constant velocity, which means acceleration which is given by this du by dt, which actually measure how the velocity is changing in time or in space, is 0, because this velocity is constant, velocity is not changing, which means the acceleration is 0, which means the overall force acting on the system should be 0. right? So this we will talk about later in the subsequent classes when we study the kinetics or the kinematics. In those classes we will study more about acceleration and velocity and how they influence the force, how they influence the distance and so on. But for now just take it from granted that the velocity is constant, which means the acceleration is zero. And if acceleration is zero, the overall force should be zero, which means you need to use the equilibrium condition. The system is in equilibrium condition, right? So again, we are using the equilibrium condition, but before using that, again, it is always advisable to make the free body diagram. So this is my 50 kilonewton force, and these are my other forces. Okay, so BAD is 20 degree from vertical and it is 30 degree from vertical. And we need to calculate these unknown forces FBC and FBD. So as usual, let's consider the summation of forces in the x direction to be 0. So the only x component forces we have is this component of FBC and component of FBD. So these two are only component of x which are acting. So it will be FBC sine 30 minus, so this is acting in the opposite direction, so FBD sine 20 equal to 0. And you know why I am writing sine 30 sine 20, because the angle is made from the vertical axis. If it is made from the horizontal axis, then it would be cos 30 and cos 20. So that's some very basic trigonometric principle. So I can write this FBC equals FBD sine 20 divided by sine 30. So this is my equation 1. Then if I make the summation of force in the y direction and that equate it to 0, then I will have the two component of forces. So here this is FBCY, here it is FBDY, and we have this 50 kilonewton also. So we have three forces. Two are components and one is directly given as 50 kilonewton. So it will be FBD cos 20 plus FBC cos 30 plus 50 equals to 0. So this is our second equation. So you can substitute equation 1 into 2. FBD cos 20 plus, so we can substitute here FBC from equation 1. So we will get FBD sine 20 divided by sine 30 multiplied by cos 30 plus 50 equals to 0. Sorry, this will be minus because 50 is in the downward direction and I am considering downward direction as minus, so this will be minus. So now you can see the equation written in terms of FBD only. So it will be 0.939 FBD So this whole term will be 0.592. So if I add this and this, it will be 1.531. FBD equal to 50. So FBD will be 50 divided by 1.531. So my FBD will be 32.65 kilonewton. So this is my FBD, and we can use either equation 2 or 1. So let's use equation 1 to calculate force FBC. So FBD is 32, this is 32.6, we just found out. And sine 20 is 0.342, sine divided by sine 30, which is 0.5. So you can straightforwardly calculate this quantity. So this is our FBC and this is our FBD. So here also we use two equations. The summation of force in x and y should be 0 in the equilibrium to maintain the equilibrium, and we use this two equation to find two unknown forces. So any doubt here? If not, then can move to the next problem. So again, the concept in this problem is also similar. So here we need to determine the magnitude and direction theta of the equilibrium force AB exerted along the link AB by the tractive apertures shown. The suspended mass is 10 kg. So this is 10 kg. Neglect the size of pulley at A. Okay. So here the concept is same, that you need to use the equilibrium, because it's already directly given in the question that we need to find the equilibrium force AB. So the only little trick is here that there is a weight or the force which is acting here in this should say cable here, which is W, and the W is mg, which is 10 multiplied by 9.81, which is 98.1 Newton. So this 98.1 Newton force is acting along this cord, which is due to this weight. So here also it will be 98.1, and here also it will be 98.1, which is acting Newton, and in this cord also 98.1 Newton force which is acting, and this is due to this cord 10. Okay, and even here also, because you can imagine, right, because if this weight is going down, it will exert force W on this cord. It will exert the same force on this cord. So everywhere in this cord there will be a same force, 98.1, 98.1, or WW everywhere. So from the free body diagram, so this red color is my axis, X, this is Y, this is force AB acting at theta, and both are unknown quantities.
and this is the force. This is point A. Okay, and let's say this is C and this is D. So this is force AC, which is W or 98.1, acting at an angle of 75. And this is AD, which is again W or 98.1, which is acting along 45.1. So force ED and force AC is 98.1 Newton. And now we need to do the force balance analysis and use the equilibrium principle to find the unknown. So we have two unknown. So only the force equilibrium condition should be sufficient. So let's use first summation of force in the x direction should be 0. So here you can see we have given the three forces AB, AD and AC, and all three forces has x component and y components. So I can write FAB sine theta. Now these two forces like AD and AC, they are in the negative x direction, right? So it will be minus FAD sine 45. Sorry, this should be cos because it's a x component. So FAB cos theta minus FAD cos 45 minus FAC cos 75 equal to 0. So this is equation 1. So these two quantities are unknown and we already know this. So FAB cos theta, so FAD is 98.1 and so FAC also is 98.1. So this is 69.36 minus 25.39 equal to 0. So FAB cos theta equal to 94.7. So let's say this is our equation 1. Then we sum the force in the y direction and equate it to 0. So again, as I said, all three forces have a component in y direction. So all the forces in the y direction can be written as FAB sine theta. So you can see this, the FAB y component is in the downward direction. So it will be minus FAB sine theta. Similarly, FAD sine 45 is in the downward direction. So it is 98.1 sine 45 in the downward direction. And this force FAC, this one, FAC, the y component is in the upward direction. So it will be positive 9.98.1 sine 75 equals to 0. So it is minus FAB sine theta minus 69.36 plus 94.75 equal to 0. So it is FAB sine theta 25.3 equal to 0, FAB equal to 25.3. So this is equation 2. Okay, so now we can divide equation 1 and 2. So FAB sin theta divided by FAB cos theta 25.3 and question 1 is 94.7. So FAB will be cancelled and sin theta by cos theta will be tan theta, which is equals to 0.267. Theta is tan inverse 0.267. So theta will be 15 degree. So you got theta, then you can use it in either question 1 or 2 to calculate force AB. So force AB cos 15 equals 94.7. So force AB will be 94.7 divided by cos 15. Just 98.13 Newton. So this is force AB. So again, by using the equilibrium principle, we can able to calculate an unknown angle theta and force. The only a little catch in this question was that the weight here is acting and it is actually exerting the same force along this cable, along the whole cable. So we differentiate the forces and we took the component of each part of this cable, and we saw that by using the summation of force in the x and y direction, then we can able to actually calculate the unknown force FAB as well as the angle theta. So any doubt in this question? So if not, we still have a similar problem here, but in this problem we have a spring force. So there is a spring attached at one end here, and we need to do the same force balance exercise here. So it's a usual force balance exercise, except that here we have a spring force. So we need to consider the spring force, which can be given as Fks. So K is a spring constant which is given, which is 800 Newton per meter, and S is the tension of the spring. So for example, let's say you have a spring here which having a natural length L. This is your length L. Now you stretch this spring to L1. So your S will be L1 minus L. And the same is also true when you compress the spring. So if you compress the spring, this is your L2, and L2 is less than the L, which is your natural length of the spring. Okay, so your S will be L minus L2. So S is basically the difference between the natural length and the new length after the elongation or compression of the spring. And K is the property of the spring that usually given in the question here. So it's a usual force balance exercise, except the case that we have given the spring force. So now we need to use the spring force here. And in the other cables, we will do the usual calculation. So first find, let us find the spring force. So in the question we have given that the spring has a stiffness of 800 Newton per meter and having the unstretched length of 200 millimeter. Determine the force in cable BC and BD when the spring is held in the position shown. Okay, so we can see that the natural length of spring is 200 millimeter or zero point 0.2 meter, and in the question it is shown that the spring is stretched up to 500 millimeter. So this is the new length, which is 500 millimeter, which is 0.5 meter. So you can actually calculate S, which is zero point 0.5 minus zero point 0.2, which is 0.3 meter. So this is the S, and we have already given K, which is 800 Newton per meter. So the spring force will be Ks, which is 800 multiplied by 0.3. So your spring force will be 240 Newton. So once you get the spring force, which is, hello, 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 can you hear? Yeah. Once you get the spring force 240 Newton, you just assume it as a regular extension cable. So it's a regular cable having the force of 240 Newton, right? And these are having the force BC and this having the force BD. So now this type of problem we already solved in the previous attempt. So now you can just use the force balance exercise. So it's in the x direction, it will be summation of force equal to 0. So it will be, first let me make the free body diagram. So this is BC, this is BD, this is spring force. Okay, and we have given the sides. We have given the each side, so we don't need to worry about the angle theta because we can use the trigonometric ratio to calculate the components. So for the x component we have force BC, and here we have a 400 millimeter length, and here we have a 400 millimeter length, which means this angle should be 45, because if you calculate the angle tan theta equals 400 by 400, it will be tan theta equals 1 and theta will be 45 degree. So FBC cos 45. Now here it is 400 millimeter and here it is 300 millimeter. So you can use the ratio and this will become 500. From Pythagoras theorem you can calculate this side, which will be 500 millimeter then. So it will be force BD 4 by 5. This is the x component. So in the first lecture we discussed that if we have only sides not angle, then how to calculate the component. So I'm using that 4 by 5 here, minus 240, which is the spring force. It's another force in the x direction, but in the negative x direction. So it's minus 240 equal to 0. So it will be 0.707 force BC plus 0.8 force BD equals 240. So this is equation 1. Then you do the summation of force in the y direction and equate it to 0. So now you don't need to concern about the spring force because the spring force is exerted only in the x direction, but there will be two force in the y direction due to force FBC and force FBD. So it will be force BC sine 45 minus force BD 3 by 5 equal to 0, because this force BD is along the negative y-axis and force BC is along the positive y-axis, that you can see in the free body diagram. So this has the direction upside and BD has the direction downside. So one is positive and one is negative. So you can solve this. So you will get force B is equal 0.848 times force BD. So that's equation 2. So now you can plug equation 2 in equation 1. So now by doing that, your equation is now depend only on force BD. That is the unknown quantity and you can easily found. That's 0.6, 0.8. So FBD will be 240 by 1.4, which is 171.4 Newton. So now you can use equation 2 to calculate force BC, which is 0.848 multiplied by 171.4 Newton. So we will get here this 145 Newton. So just to recap, again we have used here the equilibrium principle that we took the summation of x component and y component of force equals to 0. But the only catch here is, here we have given the spring forces here. So first we need to calculate the spring force by using this relation. F equals Ks. So here K is the spring constant which is given in the equation, which is 800, and S is the new length. So you can find the S from the S is basically difference between the natural length and the new length. So we have given the natural length, which is 200 millimeter, and in the diagram we have given that the spring is extend to 500 millimeter. So the difference in the length is 0.3 meter, which is S. So you calculate the spring force. Once you calculate the spring force, you just need to do the usual force balance. So just consider this force is 240 Newton, which you calculate from the spring force, and the other forces are the unknown, and you just use the equilibrium principle to calculate the unknown force. So that's the only catch here. So any doubt in this question? So okay, let's move to the next one. So now we are moving to the beam kind of problem where we have given the unknown loading, and we need to calculate the reaction for now. So there is a whole set of beam problems where we need to calculate the different kind of forces, different kind of movements, and we make the force diagrams, movement diagrams. But for now we are only concerned about the reaction forces which are acting at the end. And this reaction is there because of this different kind of force and movements which are acting here. So this force and movement, since this beam is constant at one point, it's fixed at one point, the number of forces and movements which are acting at the right hand side will create some reaction forces and some movement at the fixed point, and we need to calculate these reaction and this movement at fixed point. So this exercise will be very beneficial when we in the future solve the when we actually solve for the force diagram and the bending moment diagram for the beams. The first step usually will be to actually find the reaction forces. and then we actually do the analysis. Even in the truss problem, like for example, if you have given the truss here, and this truss is actually fixed at this both point. The first step is to find the reaction forces here. Once we get the reaction forces here, then we actually can solve for the forces in each member of this truss by equilibrium method or by another method. Similarly, in this cantilever beam, or there are various kinds of beam, simply supported beam, for example, it is just supported at the two ends. The first step is to find the reaction, and then we do the further analysis. So for now in this class we will be finding reactions only by using the equilibrium method, and we will also find the movement that will be acting due to these different kind of forces, because from this diagram itself you can see that this force has a perpendicular distance, and this force also has a perpendicular distance, plus there is a moment which is already acting. So these two forces and this movement is actually creating the opposite movement here at the fixed point, because this is a because at this point the beam is constant, the movement of the beam is constant, so there will be opposite movement which is acting at a fixed point due to these forces and this movement. So we have to calculate this movement and force, unknown reaction forces. So let's make a free body diagram first. So this is 2 kilonewton at 60 degree. This is 4 kilonewton, and there is a moment here which is 6 kilonewton meter, and here we have a force AY, AX, which are the reaction forces, and we need to calculate these reaction forces, and the moment MA. So we need to calculate these quantities. So this 2 kilonewton force has a component 2 cos 60 and 2 sin 60. Okay, so let's use the equilibrium conditions. So the first condition is Fx, summation of force in the x direction is 0. So the only force we have is Ax and plus 2 cos 60 equals to 0, which is Ax plus 2 multiplied by 1 by 2 equals 0, Ax plus 1 0, which means Ax equals to minus 1 kilonewton, which means the Ax direction of Ax is here, and it is 1 kilonewton. Then we use the summation of force in the y direction, and we will equate it to 0. And we have a force Ay plus 4 plus 2 sine 60 equals to 0. And we have Ay plus 5.73 equals 0. So Ay equals to minus 5.73 kilonewton, which means the direction of Ay is this, and it is equal to 5.73 kilonewton. Now we will do the moment balance at A, and according to the equilibrium principle, the moment at point A should be 0, and the moment is caused due to this force because it has a perpendicular distance this force because it has a perpendicular distance this, and by this movement. And this force have a counterclockwise direction around point A. Both these forces have a counterclockwise direction, and the couple is acting again in the counterclockwise direction. So the counterclockwise direction I am taking positive, so it is 2 sine 60, and the perpendicular distance is 1 plus 1.5 plus 1.5, which is 4, plus ma, which is the unknown movement we need to find, plus 6, which is the movement here given in the question, plus this 4 kilonewton force multiplied by its perpendicular distance, which is 1 plus 1.5, which is 2.5. So it's 4 multiplied 2.5 equals 0. So it's 1.73, 2 plus ma plus 6 plus 10 equals 0. So ma is minus 17.732. Sorry, this should be 6.928. So it will be minus 22.9 kilonewton meter. So the direction of ma should be this, because it's minus, which means it should be in the clockwise direction, because positive is the counterclockwise, and the magnitude of ma is 22.9. So just to recap, we have given the beam and we need to find the reaction forces here. So there will be two reaction forces and one movement for the fixed case, and we use the equilibrium condition to find these reaction forces as well as the movement. So any doubt here? So let's solve a similar problem. Here, so in this question we need to draw the free body diagram, and again we need to calculate the reaction at the supports. So as we have discussed at the beginning of this class, the reaction force depend on what kind of support you have. So for example, for the roller support, you have only one reaction force, which is Ry. The roller is this, because it can move in the x direction, and only reaction force is Ry. If you have a pin joint, then the motion is constant, translation motion is constant, and you can have reaction forces Rx as well as Ry for the pin support. So in this question you can see that at A you have a roller support and at B you have a pin support. So this is roller and this is pin joint. So here you have only one reaction force, which is this Ra, and here you have two reaction force, because both x and y motion are constant. So you have motion, so you have a reaction force in both x and y. So it is Rby and this is Rbx. Okay, so this can be easily visualized from the free body diagram. So this is point A and you have a reaction force Ra. Here you have a 40 kilonewton force, and this is B, and the reaction forces are Rby and Rbx. and we need to find these reaction forces. And you can see that you have three unknown quantities, which means you need to use three equilibrium conditions. And you can take a moment around point B. Okay. So you can, by inspection, you can see that if you take the movement around point B, at this point, if you take the movement, then the contribution to the movement from this force will be zero, and there will be a contribution only from this and this force. So from this movement equation alone, you can actually find this unknown force, right? Because this is the only force which is contributing to the movement at point B. If you consider, you can also consider point A. You can take the movement along point A, but then there there will be a contribution from the force, this Bx, Rbx as well as Rby. So the movement condition, so the movement equation alone will not give you the suitable result, but nevertheless, if you use other two force condition, you will anyway get the answer, right? So let's use a movement at point B, because then we can easily, in one step, we can easily find the unknown force Ra. If you use the movement at point A, you cannot find both unknown force from this equation, but by using all three equations, you can find the unknown force. But if you take the moment at point B, then only from this equation at least you can find this equation. Again, you have to use all three to calculate the other unknown forces. So you can check whenever you take the movement, you will just check at which point I should take the movement to uh, simplify the calculation. So it is just about the simplifying the calculation. So if I take the moment at point B and equate it to 0, then I can simplify the calculation a bit, because then I need to consider only Ra and 40 kilonewton force, because these are the only forces which are creating the movement. So this Ra has the perpendicular distance, this, which is 6 meter, and 40 kilonewton has the perpendicular distance, this, which is 4 meter. So Ra has the direction, rotate like this around point B, which is in counterclockwise direction, and 40 kilonewton force rotate like this, which has a clockwise direction. So both should have a different sign. So I'm considering counterclockwise is positive and clockwise is negative. So Ra 6 minus 40, 4 equal to 0. Multiply by 4 equal to 0. 6 Ra equals 160. So my Ra will be 160 by 6. Which is 26.66 Newton. Now I can use force balance. So let's sum the force in the x direction and equate it to 0. So my forces which are in x direction are Ra and Rbx. These are the only two forces. And you can see the direction, both are in the opposite direction. So Ra minus Rbx, or you can do otherwise. So it will be Ra equals Rbx. And we already found Ra, which means Rbx and Ra is equal, and Ra is 26.6. So Rbx is also 26.6 Newton. Then we do the summation of force in the y direction and equate it to 0. So we have forces like 40 and Rby in the y direction, and it's both are in the same direction. So you can see that Ry is minus 40 Newton, which means the direction of Rby should be this. So again you can see that you by using the equilibrium condition you can able to find the reaction force here, and you can also find the movement just like we did in the previous question. So here we need to identify the type of joint we have. So from the figure we identify that one has the roller joint and one has the pin joint, and the roller joint can move in the x direction, so only the reaction forces in the vertical direction, whereas pin joint cannot move. So we have RBY as well as RBX. But why we are not considering the movement here? Like here we consider the reaction force and the movement which are there in the fixed support. But in the pin joint, there will be no movement. We just consider these two reaction forces. And the reason is this pin joint can actually rotate. Just like a roller support here can translate in x direction, pin joint cannot translate. So there are two reaction forces, but it can actually rotate. Therefore, there is a no bending moment which is actually exerting in this pin joint. But in a fixed joint, what happens? It cannot translate and it cannot rotate. So there will be two reaction forces and there will be movement, reactive movement also. So here we don't have a reactive movement, we have two force. Here we have only one force and no reactive movement. But for a fixed support, we have one reactive movement and two reaction force. And this you can easily remember once you visualize the situation in your mind, because this the motion, the rotational and translation motion here is constant. So you have all three. In the pin joint, the rotational motion is not constant, so you don't have a reactive movement, but you have a reactive force because the translation motion is constant, not a rotational motion. Whereas in roller support, the translation motion is constant only in the y direction, so you have a reaction force in y direction, and you don't have the constant rotational motion as well. So once you identify the type of joint here, you can uh, easily calculate the reaction forces and the reaction movement here. You have any doubt in this question? So if not, then we have a similar problem here, and you can try this problem by yourself. Okay, so just for the hint, I can say that first you need to identify the type of joint here. So this joint is say a roller joint, and this joint is pin joint. Okay, now you have a pin joint at A, roller joint at B, and now you need to calculate the reaction at A and B. So just identify whether how many reactive forces are actually acting at each joint and whether there is a movement, reactive movement or not, and then calculate those reactive forces and reactive movement if there are any. So it's a similar problem, almost similar problem that we have just solved, and similar to the previous one as well here. And you just need to use the same principle. So you need to use the same equilibrium principle. So write down the equilibrium equation. So if you have a two unknown, this two equation is satisfied, but if you have a three unknown, then you need to consider the moment about some point O and equate it to 0. So these are the complete set of the equilibrium equation. So use this equation to calculate the reaction and the reactive moment here. And the procedure is very almost similar to what we have shown in the previous two questions here and here. It's the same procedure you need to follow. And it's not even about the procedure, it's all about the concept here. Yeah, you have any doubt, Mukesh?
Hello.
Hello?
This actually I have a doubt. So in the previous question,
Yeah,
so just previous one. Okay. So they're just next one. Just next one.
this one?
Yes, sir.
Yeah.
So in this question, I have a doubt that how a movement can actually work in a middle of the beam. So this is always my doubt when I was studying in the question. How a movement come into picture in the middle of the beam. Suppose in a building there is a beam that is a fixed, and we suppose in the mechanics that all system are in equilibrium condition. So how a movement come into this?
So here, this thing, right? How this movement is come between the beam, right?
Yes, sir, yes, sir. Yeah, right,
So,
right.
so you can actually consider this movement as a couple. Okay, so this is actually act as a couple. So in the previous lecture, in the first lecture, what we discussed that, let's say you have a body. Okay, let's say this is your reference point O. This is your
Okay,
another point B. Let's say this is F. So let this is a point A. This is point B, and let's say this is another force minus F. So this is the example of a couple. So here the net force is zero. If you do the
okay,
summation of force, it is zero because it is just F minus F. F minus F equal to
yes,
zero. But there is a movement because the distance is different. So let's say this is distance x and this is distance 2x. So you can see there is a movement about point O. So there is a movement, let's say F Fx from this force, and there is a movement here minus F2x. So you can see Fx plus F2x, which will give you 3Fx. So there will be a finite movement, but there will be no force at all. So this is the example of couple. So this is actually what couple is. So you can actually consider this system as a couple, which means that there might be a two equal and opposite forces which are acting, F and minus F, which is such that the net force here is zero. So there is no net force here, but there will be a movement. There will be some finite movement which is acting. So this is what couple does. So in a couple, the net force is zero, but there will be a finite movement which is acting. So this is how the couple is acting in between the beam or in between the building. When there is a no net force,
okay,
but there is a finite
okay.
movement.
Sir, actually, the moment is come from this force, 4 kilonewton or 2 kilonewton. By the effect of these two forces, moment came into picture.
No, this movement can actually uh, affect the reactive moment here at the fixed point. At the fixed point, there will be the reaction to these forces and to these movements. So this will influence this reaction movement. But this is an independent quantity.
Dependent quantity.
Yeah. This is the
Okay.
independent quantity. This and these are the independent quantity. So if you want to know if there is an effect of movement from the forces, what you do, you just draw the beam here.
Okay.
Let's say these are the forces which are acting. You just keep considering different point, and you calculate the movement at this different point, and you will see that how the movement is varying about each point, and then you will see that what is the action, what is the effect of the forces or the reaction to this movement at different points. That actually what we will do when we actually do the when we actually draw the bending moment diagram or shear force diagram in the beam. Maybe in the future we will study that, but this is what exactly we actually do.
So, just we can consider it that there is a moment which acting
Yeah, so this
like
is
that. If in a question given that a moment is acting, then we have to consider it that it is acting in the beam.
yeah, yeah.
Okay. or by the fourth Newton is also there is a effect by the fourth Newton, no? Moment.
Sorry,
There is also a moment which is said. There is also a moment
hmm.
that is caused by the fourth Newton force. Am I right?
Yeah, yeah,
In a point A, and in
yeah,
a
yeah,
point A.
yeah, yeah. Yeah,
Okay. So in a if you
this is actually can be given if you break the two kilonewton force into components. So we break this in x and y component here, and
X and Y component.
we saw that only y component is creating movement because it has a perpendicular distance, whereas this x
Okay.
component is
Yes.
don't have any perpendicular distance, so it will not cause any movement at point A.
Yes. I got it. Sir, can you provide us a PDF of this lecture, if possible?
That I will do every week. So the last time I took a little time to upload the PDF, but this time I will keep uploading both this video and this PDF in the Google Drive.
Okay. Yes. Thank you, sir.
Yeah. So yeah, just try this problem. It's a very similar problem that we have. Yeah, Shivam. Yes.
Actually, I have a question. If it's better, if you can you open the video like fourth lecture at 10 minutes 17 seconds. If that is the slide, then it is easy to like tell.
I don't understand. Like upload the video of what?
No, no, not upload. I am saying the lecture videos. If you can open the lecture videos, lecture number fourth at 10 minutes 17 seconds, then I can explain my question in a better way.
Lecture number 4 of NPTEL, right?
Yeah, yeah, yeah.
Just a second. Okay, so which lecture can you again repeat?
Fourth one, week one, fourth lecture
Okay, yeah,
at 10 minute 19
Module
second,
1
19 or
static
17 second.
10 minutes, 19 seconds.
Yeah.
Okay, yeah. So, yeah, so
So
here,
can you please
yeah.
show it?
Yes, so he's describing about the movement equation, right?
Yeah, but if yeah, can you please show it the screen here?
Uh, well, just a second, because I'm projecting the screen from tablet
Yeah.
and I just opened the lecture in the laptop.
So,
Just 2 minutes.
yeah, 10.
Yeah, you can ask if you can able to see the video.
Yeah, you can pause at 10 minutes 19 seconds if you can, please. 10 minutes 19 seconds. Yeah, just here. This equation. Okay, yeah. So I want to ask, like, in this equation,
Hmm.
uh, this this E dot, first thing, there are two questions. First thing is, this E dot R is a dot product, so it will give a scalar, and how we can take a scalar over and cross product it with a vector F.
Yeah, I mean it should be a vector quantity. So see, no, the so it should be R cross F. So there should be a R cross F term. I mean, so not E.
No, no, no. Actually, we are taking in this, but let me tell a little bit. In this video, like at this point, sir is explaining that if we want to take a component OO across, considering OO prime as the our axis,
Hmm.
instead of OO, we are taking it O prime. So we have
Okay.
E cap E vector, which is like unit vector in that direction. So to have this component, he said that we can take dot product of E dot R and then cross product it with F. So my doubt is, this E dot R gives a quantity scalar.
Yeah.
So how can we take this cross product with F?
Yeah. Yeah. There might be some issue here.
And the second part of the doubt is, can I say it now?
Yeah. Yeah. Yeah.
Hello.
Yes. Yes.
Yeah, the
Sure.
second part is like, this this E vector is, he said, is a unit vector in OO prime direction. So definitely E dot R will give projection of either E to R.
Yes.
But why would we take the projection? Yeah, but why would we take the projection of unit vector in R direction? Like we need to have a like a position vector of this F along this O prime. So if we
No.
take a unit vector in O prime direction, and
No. So
yeah,
actually, that projection vector is act like a shadow. For example, just imagine like you have imagine a projection like a
yeah,
shadow,
that's fine.
and that shadow will be
Yeah,
now new perpendicular distance. That is actually the new perpendicular distance at the O dash axis, and that's why it is you need to consider its projection
no, no.
because
Like if we take E dot R simply, E dot R. So yeah, either R is projected on this, along this direction of E, or
yes,
E is projected on this R. Yeah. So but because it is written E dot R, it means that E is projected in the direction of R, right?
well it's a dot
Otherwise
product.
it would be R dot E.
No, it's a dot product. So
Yeah.
basically, it could be R dot E or E dot R. I mean, it's not a cross product that the sign or the quantity will change if you
No,
have R
what
cross R.
no, but my thing is, like, in which direction we are interested. If we are trying to find out the component along O prime,
Yeah.
then when we are taking it along O, then we are from P to that F point, we have this R, right? But
Yes. Yes.
now for O prime, what is the distance we are interested in, which we are finding from E dot R?
Hmm. Yeah.
And then this is the one part of doubt, and the second and the first one I already told you,
Yeah. Yeah.
that it will give a scalar. So mathematically, how we can take the cross product with that vector?
So the thing is, if you change the axis O to O dash O dash, the R vector will get changed, but it is, I mean, definitely will not be a scalar quantity. It should be a vector quantity. So something is there actually, which may be not correct here. Uh,
Yeah, like even this direction I'm not able to understand. Like if instead of O we are taking O prime, then in which position vector we are interested? Like when it is O, it is very clearly understood that R vector is from P point to that point. But when it is O prime, then like in what vector we are interested, what we are finding it from E dot R.
yeah, yes, yes. So it will be like this. So first you have this O, and this is your R vector, and this is your force vector, and the movement can be given by
Yeah.
R cross F.
R,
Now
yeah.
you have a new axis here, O dash, O dash, and what you are doing now, the system is lift up. So this is your R vector, and this is your F vector. So now this is your new R dash vector. So now the thing is how to define this R dash vector. So this is your new movement along O dash, and this will be your movement R dash cross F. But this is the thing, how to define this R dash vector here. So the
Even
vector,
even here you have shifted that F. How F can be shifted there? It can be transmitted along a particular line. That's okay. But how you have shifted it to the other side? Like you have given it an angle.
sorry, it should be like this only. I mean the direction of F will not exactly change, but it should be like this.
Even the point of application cannot change. Like it may change along the line of like along the line of action it may transmit, but how it can go there like on the backside? Like visualizing it is a quite difficult thing. That's why I'm asking.
Yeah, okay.
Yeah,
Let me
yeah.
consider
This
like
could be
this. Yeah. So this
yeah.
could be
That could be
now,
a thing.
yes, this could be into R dash vector. So I think the one way is to do this. I don't know. So since the axis got changed, you can actually use the transformation matrix. For example, let's say you have this x and y vector component of vector. If you transform to some other axis, x dash and y dash here, you have to use some rotation matrix like cos theta, sin theta, minus sin theta, cos theta. And this theta is the angle between these two axes. This is our theta. So by this algebra, you can actually convert this set of axes, which is OO, to this axis, which is O dash O dash. And subsequently, you can actually change your R to R dash as well by using this rotation matrix. So it will be R dash equal to this rotation matrix dotted with R. So you can see this matrix is dotted with vector, so it will result into a vector which is R dash. So this R dash can be then have a cross product with F, or you can write like R, this rotation matrix dotted with R multiplied by cross product. So both are the same thing. So I mean this is one
Yeah,
of the
this I
another way,
understood, but
but I mean
yeah,
in
this
context
procedure is
of,
okay. Like
yeah,
this I understood.
in context of
Yeah, this procedure
video,
I understood. Like there is no problem in.
yeah. But in context of
Yeah,
video, I
but
mean there might be,
what he's
yeah, I mean there might be some small issue. I mean
it-
in equation there might be some
yeah, what he said
yeah,
what he said actually what he said that we can can have a unit normal vector in that direction, like that is E vector in O prime direction, and we can simply dot product it with R vector.
Yeah,
Like this procedure is okay. This is quite detailed procedure, like rotating the axis and
yeah,
then
yeah.
going there. But what he said is very direct way, like just taking a dot product with a unit normal vector is that.
Yes, yes. Okay, so let me go through that, and let me come next week.
Yeah,
Maybe I have some solution
yeah,
for
sure,
that.
sure.
Yeah,
Yeah, sure, sure.
yeah.
Thank you, thank you.
Thank you. Yeah,
And
sure.
also, please, like how, like imaginary, like if it is imaginary, then it would be like the same way as you have drawn, or it could be a different way. Please, like
Yeah, yeah.
check
That
that also.
that only I will
Like
check,
how
because doing simply
yeah,
a
please.
dot product with another vector definitely will give you some a scalar quantity that cannot be used in the cross product. So here you are dotting with the matrix, which eventually lead to a vector, so it's fine. But
Yeah,
let me
and
see.
also like visually, yeah, like also visually, like where could be that vector after
Yeah,
taking the projection, exactly what is the, like how we can imagine at this location it would be that vector, like this projection from E to R,
yeah,
right?
yeah.
If you can also look at it, then it will be of great help if you can also look at it.
Sure, sure. Yeah, I mean, I will check that.
Okay. Okay. Thank you very much.
Okay, then we will meet in next class. And till then, anyway, try to solve this problem. The other problem are very much similar, and we will solve this problem in the next class. So, thank you.